For a brief moment in history, we thought we had found the edge, not the edge of the universe, not the edge of what physics could explain, the edge of what a black hole could become. Its name was Dethroned 618, and for years, it sat at the top of every list, every chart, every scientific paper on the subject of ultramassive black holes. The undisputed record holder, the largest single object ever directly measured in the observable universe, 66 billion solar masses, 66 billion times the mass of our sun. A star so large that 1 million Earths fit inside it, compressed into a single gravitational singularity so extreme that the mathematics describing its interior are not equations anymore. They are approximations, guesses, the boundary where human understanding goes in and does not come back out. We called it the king. We built our models around it. We calibrated our understanding of how massive black holes could grow against it. We assumed, with reasonable confidence, that nothing in a 13.8 billion-year-old universe could exceed it. We were wrong. If you love learning about space and uncovering its mysteries, subscribe, hit like, and leave a comment. If there's something we can do better, I genuinely want to hear it. And the object that dethroned it didn't just surpass it by a small margin. It didn't edge past by a few billion solar masses. It arrived at more than 100 billion and forced an entirely new category of classification into existence, just to describe what it was. But before we talk about what came after Dethroned 618, we need to talk about what Dethroned 618 actually is. Because most people have heard the number, almost no one has understood the thing. Dethroned 618 sits approximately 10.4 billion light-years away, which means the light we observe from it today left when the universe was less than 4 billion years old, when the first complex stars were still forming, when the first galaxies were still assembling themselves from the chaos of the early cosmos. We are not seeing Dethroned 618 as it is. We are seeing it as it was 10 billion years ago, in an era of the universe so different from ours that the sky would have been unrecognizable. It was discovered in 1970 by a French survey and catalogued as a quasi-stellar object, a quasar. For decades, it sat quietly in databases, known but not fully measured. It wasn't until 2004 that astronomers used spectroscopic analysis to pin down its mass with precision. 66 billion solar masses, confirmed through the behavior of gas orbiting at its innermost stable orbit. The measurement sent a ripple through the astrophysics community, because up until that point, the theoretical models, the equations describing how black holes grow through accretion, through mergers, through billions of years of consumption, suggested that 66 billion solar masses was close to the upper boundary of what the universe could produce. The Eddington Limit, the physical law that governs how fast a black hole can feed before its own radiation pushes its food supply away, seemed to place a ceiling on growth. An ultramassive black hole feeding at maximum rate from the very beginning of cosmic time should not be able to reach much beyond what Dethroned 618 had achieved. Dethroned 618 was not just the largest black hole ever found. It appeared to be approximately as large as a black hole could get. That was the belief. That was the model. That was the foundation everything else was built on. If this is already making your sense of cosmic scale feel unstable, you're exactly where you're supposed to be. Subscribe to Beyond Orbit. Every week, we go somewhere the textbooks are afraid to follow. Now let's talk about what Dethroned 618 actually looks like, because the number alone doesn't prepare you for the geometry. The event horizon of Dethroned 618, the spherical boundary of no return, the point past which not even light can escape, has a diameter of approximately 196 billion kilometers. The distance from our sun to the Earth is 150 million kilometers. The distance from our sun to Pluto is 9 billion kilometers. Dethroned 618's event horizon is 33 times wider than the entire orbit of Pluto around our sun. If you replaced our Sun with 2N618 at the center of our solar system, the event horizon would swallow Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, Pluto, and extend billions of kilometers past the edge of our known planetary system before it reached its outer boundary. Every planet you have ever seen in a photograph, every world any spacecraft has ever visited, every surface any probe has ever touched, all of it gone. Inside the event horizon, not destroyed, not consumed, simply inside the place where the rules stop. And this was the smaller one. The moment everything changed came quietly. Not with a press conference, not with a single dramatic discovery announcement, but with data, X-ray data specifically, from telescopes designed to observe the hottest and most energetic structures in the universe. The Phoenix Cluster had been known since 2010, when the South Pole Telescope, an instrument in Antarctica designed to detect distortions in the cosmic microwave background, flagged it as one of the most massive galaxy clusters ever mapped. The cluster itself was extraordinary. Hundreds of galaxies, superheated gas at 100 million degrees, a cooling flow more powerful than anything previously observed. But no one had yet looked closely at what sat at its center. When the mass measurements came back from detailed X-ray analysis, when the data had been checked and rechecked, and the number had been confirmed across multiple independent methods, it was approximately 100 billion solar masses. TON 618 was 66 billion. Phoenix A was a 100 billion. The gap between them, 34 billion solar masses, is itself larger than every previous record holder in history, except TON 618. The margin of defeat was larger than almost any black hole we had ever found. The king had not merely been dethroned. It had been made to look small. But here is the part that genuinely unsettled the scientific community. TON 618, reaching 66 billion solar masses, was already at the edge of what the models predicted was possible. The Eddington Limit, applied across 13.8 billion years of cosmic history, suggested an approximate ceiling, and TON 618 was brushing against it. Phoenix A at 100 billion solar masses was not brushing against it. Phoenix A had gone through it, which means one of two things must be true. Either the Eddington Limit does not work the way we thought it did, or Phoenix A did not grow by the method we assumed. If it grew by consuming gas and dust and stars over billions of years, it should have choked its own growth long before reaching 100 billion. The radiation pressure should have pushed its food supply away. It should have regulated itself. The first possibility is that Phoenix AU grew by consuming other black holes, massive ones, repeatedly, bypassing the need for gas entirely. In the early universe, when galaxy mergers were constant and cosmic density was almost incomprehensible, ultramassive black holes may have merged with each other again and again in a cascade of collisions. No gas needed, no radiation, just gravity consuming gravity, over and over, until what remained had no precedent. The second possibility is stranger. Phoenix A may have been born, not grown, not formed from a collapsing star, not assembled through billions of years of feeding, but forged directly in the first fraction of a second after the Big Bang. As a primordial black hole, a flaw in space-time itself, created when quantum density fluctuations in the newborn universe collapsed certain regions before a single proton had yet combined with a single electron. If that is true, Phoenix A is not just larger than TON 618, it is older than every star that has ever existed, older than every galaxy that has ever formed, older than light itself as a free-moving thing in the universe. It was there in the dark before the dark ended. Tell me in the comments, does it change how you think about TON 618 to know something exists that makes it look small? Or does every new record just make you feel like the actual limit is always one discovery further than wherever we are? I read every response. TON 618 is not diminished by this. Understanding why matters. TON 618 taught us the ceiling. It showed us what the universe could build through known processes operating over billions of years. It gave us the benchmark against which everything else would be measured. Without TON 618 sitting at 66 billion solar masses and appearing to represent the upper boundary of what was physically possible, the discovery of Phoenix A at 100 billion would not have been shocking. It would have just been a number. TON 618 made Phoenix A impossible, and in making it impossible, made the discovery of it mean something. The two objects are not rivals. They are a sequence. TON 618 is the question. How large can a black hole actually grow? Phoenix A is the answer, larger than the question was allowed to ask. And somewhere in the observable universe right now, there are almost certainly other objects we have not yet measured, other structures sitting at the centers of other massive clusters in the deep regions of space beyond our current survey coverage, with masses that would rewrite the question again. TON 618 reigned as champion for years. Phoenix A arrived and made it look small. The next discovery hasn't been named yet, but the universe is not finished. It never was. Keep looking up.